10.3 Composite Functions, last lesson of 30-1. Composite functions are functions that are formed from two functions. You have an f of x and a g of x function, in which the output of one of these functions is used to find used for the other function. So this g bracket f bracket x bracket bracket is read as g of f of x, or g, like this is open circle, f of x. Is another way of writing g of f of x, and it's read in the same way. So if it's an open circle, it's composition. If it's a closed circle, it's multiplication. And so this g of f of x, like with the little circle, open circle, you'll rewrite it as g of f of x. So whatever comes second after the open circle is what you put in the brackets. Now we know whatever the heck is in our brackets, we always fill in for g for the value of x of the function. So this will make sense in a little bit. So we have g of f of x is g of f of x. This is read as g composition f and means to copy the g function down, but wherever you see an x, you substitute in the f function. So we have, this is the f function, 2x squared plus 3. So we have g of f of x, and instead of writing f of x, I'm going to write 2x plus 3, like this one has here. So I'm going to go g of 2x plus 3, 2x squared, sorry, plus 3. Because that's what f is. F is that, so I'm going to put that where f was. Okay. Now remember, we were told whatever's in these brackets beside the letter g is going to go in for the x's in g. So if I had, for example, g of 2, let's say, and g is 4x cubed plus 1, I would go 4 times 2 cubed plus 1. So it would be 4 times 8 plus 1, which is 32 plus 1, which is 33. I just get a plain old answer. Whenever I have just a number in my bracket, I get a number answer. But instead of having a number of 2, I'm actually taking this x here in the g of x, and I'm going to replace it with 2x cubed, 2x squared plus 3. So here I have 4 is rewritten as 4. The x is replaced with brackets as 2x squared plus 3. And then the cube stays, plus, cube's erasing, bracket, then the cube stays, and plus 1. So the only thing I did was replace the x with 2x squared plus 3, because instead of it just being g of x, which it usually is, it's g of 2x squared plus 3. So this goes in for all the x's in g. So when there's a physical number, we're going to actually solve these out. So I'm going to find g of 1 first. If I solve for g of 1, then I can plug it into that bracket. So g of 1 says example 1, given f of x equals 3x minus 5 and g of x equals negative 2x plus 7, find each value. So g of 1 is going to be negative 2 times 1 plus 7. So it's going to be 5. So I know g of 1 is 5, so I can take g of 1 in here and replace it with 5. So g of 1 is going to go away, and I'm going to put a 5 there. So now I'm going to find f of 5. So f of 5 equals 3 times 5 minus 5, because wherever there's an x, I'm going to replace it with the 5. That's what you do when there's brackets in function notation. So I'm going to go 15 minus 5. My answer is 10. So f of 5 is 10. So f of g of 1 actually equals 10. You're just going to do it in 2 steps. You're going to find g of 1 first, put the 5 in its place, because that's what g of 1 is, and then find f of 5, which is 10. So now for this one, I'm going to find, for b, it's f of g of negative 4. I'm going to find g of negative 4 first. I'm going to do it over here. G of negative 4 equals negative 2 times negative 4 plus 7, because I'm just replacing the x with negative 4. Negative 2 times negative 4 is 8 plus 7, so it's going to be 15. So I'm going to replace g of negative 4 with 15. So now I'm going to have f of 15. So now when I find f of 15, it's just going to be 3 times 5 minus 5. 3 times 15, sorry, minus 5, which is 45 minus 5. So it's 40. So the answer to f of g of negative 4 is 40. Example 2. So given f of x equals 8 minus 2x and g of x equals x squared plus 3x plus 4, find each value. So first we're going to find g of 1. So g of 1 is 1 squared plus 3 times 1 plus 4. So it's going to be 1 plus 3 plus 4. So g of 1 is 8. So in for g of 1, I'm going to put in an 8. So I'm going to find f 8. So I'm going to do 8 minus 2 times 8, which is 8 minus 16. So my answer is negative 8. F of g of negative 4. So I'm going to find g of negative 4 first. G of negative 4 is negative 4 squared plus 3 times negative 4 plus 4. So I'm going to get 16 minus 12 plus 4, which is 20 minus 12, which is 8. So g of negative 4 is 8. So I'm going to find f of 8 because I'm going to replace g of negative 4 with 8. So I'm going to get 8 minus 2 times 8, which is 8 minus 16, which is negative 8 again. All right, next page. Now for using the graph, instead of us solving the for f of negative 1 from an equation, we're going to find the value of f of negative 1 off the graph. The f is not the straight line, it's the absolute value function graph. So it's this one here. So we're going to try and find when f is negative 1. So f of negative 1 means when on the f graph, when x equals negative 1, what's the y? So I go to the x equals negative 1. What's the y? The y is 4. So f of negative 1 is actually 4. So I'm going to fill in for f negative 1, 4. So now I'm trying to find g of 4. So I go to where x is 4, follow it up to the g graph, follow it over. Y is 4 for that one as well, because we're looking at the other line now. And there's my answer. Now, say I'm finding g of f of negative 2. So now I'm finding f of negative 2. So I'm going to look for when x is negative 2 and look for what the y value is. So when x is negative 2, the y value of f, so x is negative 2, the y value of f is 5. So I'm going to fill in for f of negative 2, 5. So I'm going to go g of 5. So I'm going to go to where x is 5, follow it up to the g function, which is here, follow it over. So at g of 5 is 6. We're done. Now, for A, B, and C, it gets a little more dicey in example 4, just because you don't have a value to fill in for x, so you're going to be filling in an actual equation. So how I do this, when it gives me this, it says example number 4, if f of x equals 2x minus 9 and g of x equals x squared plus 6, determine each of the following. So f of g of x, this could have been written like this, f open dot g of x. Okay, that's f of g of x anyways, but you're never going to keep it like this fog. We're going to always rewrite it like the question actually started. Okay? So instead of replacing g of 1 with a value like 4, 7, 8, we don't have a value for x. So we have to actually replace g of x with whatever g of x is. So when I replace g of x, I'm going to get f. That's going to stay the same. The bracket's going to stay the same. G of x now is going to be replaced with x squared plus 6, which is what g of x is. And then close the bracket. Now what we're going to do is f of x squared plus 6. If it was f of 2, I take 2 and fill it in for all the x's in f. But if it's f of x squared plus 6, I'm going to take x squared plus 6 and fill it for the x in f up here. See? So I'm going to get 2, and instead of x, I'm going to take that x beside the 2 and I'm going to throw it behind my head, and I'm going to replace it with x squared plus 6. I'm going to close the bracket, and then I'm going to write minus 9, because that didn't change. The only thing that changed is the x got replaced with x squared plus 6. Now I can distribute. 2 times x squared is 2x squared. 2 times 6 is positive 12 minus 9. Calculate terms, and I get 2x squared plus 3. Okay? Now what if it's g of f of x? So this would be written like this. G open dot f of x. And if it was written like that, you would always go and rewrite it like g of f of x with the brackets. So now I'm going to take that f of x, and I'm going to write the g, I'm going to put the bracket, and I'm going to replace the f of x here with f of x. F of x is 2x minus 9. So what does that mean? That means in for this x squared in the g, I'm going to take that x, I'm going to throw it out, and I'm going to replace it with 2x minus 9. So what does that mean? I'm going to get 2x minus 9, but it's going to be squared because the function g of x equals x squared plus 6. So what am I doing? I'm taking this x here that's in brackets, I'm going to throw it out behind my head, and I'm going to replace it with 2x minus 9. So it has to actually get squared, then plus 6. Now what did I tell you whenever you have a binomial squared? Take that squared and just cross it out and rewrite the 2x minus 9 twice so that you don't forget to FOIL. 2x minus 9, 2x minus 9, plus 6. FOIL it out, and you're going to get 4x squared minus 36x plus 81 plus 6. And so you get 4x squared minus 36x plus 87. And that's going to be your new graph, the graph of g of f of x. Now what if it's f of x? Well, I'm still going to do the same thing. I'm going to rewrite the f on the outside in brackets, and I'm going to replace this f of x with whatever the heck f of x is. F of x is 2x minus 9. So now I have the function 2x minus 9 is what f of x is, right? So instead of writing f of x, I have f of 2x minus 9. So this x here is going to get replaced with 2x minus 9. So I'm going to get 2, because the 2 stays, 2x minus 9, bracket, minus 9. And so I get 4x minus 18 minus 9 equals 4x minus 27. Now we're going to example 5. Consider f of x equals x squared minus 5 and g of x equals square root x plus 2. So they want us to determine f of g of x. So the first thing I do is I take this little g of x and I replace it with what g of x is, which is x plus 2. Now remember, we now have f of square root x plus 2. That means at some point in time, I'm going to insert an x square root of an x plus 2. If there is ever, even if it gets canceled somewhere along the line by a squared, if there's ever a square root, remember you have to state restrictions because you can't have a negative number in the square root. So I'm going to take this and I'm going to replace it into f. F is x squared minus 5. So I'm going to say instead of the x squared, I'm going to have square root of x plus 2 squared, because I'm going to replace that x with square root x plus 2, and I'm still going to write the minus 5 at the back. Now it doesn't matter that this squared cancels out the square root. Before that happens, you still have to state non-permissible values, because at some point in time there was a square root function in your equation. Just like if when you're doing a rational and a factor cancels off on the top and the bottom and you don't have a denominator anymore, you still have to state the non-permissible values of that denominator before you cancel it. Same thing here. Before we cancel out this radical, we need to state the non-permissible values of that radical because it's going to affect it. So we have x plus 2 has to be greater than or equal to 0. X has to be greater than or equal to negative 2. So when we go to draw this graph, we have to keep that in mind. All the values below negative 2 on the x won't exist. So we actually have the line x plus 2 minus 5. So it's going to be x minus 3. That's our equation. Now, if we go to draw that, straightforward because it wants us to sketch it, if we go to sketch that graph, it's a line, right? It's a line. Don't draw this till we're done because I'm going to draw it wrong first. So it's a line, y-intercept of -3, and I have 1 over 1 slope. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And I draw this line. And if you pick that answer as your equation on the diploma, you're wrong. Because there's actually no graph less than -2, because that was my restrictions. So this is actually the graph of f of g of x. Now, if you want to test this out on your calculator, if you put just your answer into your calculator, so if we just put in x minus 3, we're just going to get what I drew, right? We're just going to get that line. No restrictions, no nothing. So when you go to plug it into your y equals, always plug in just your original inserted d into f. So what I'm going to plug in is this original part right here. Before I canceled that squared, because the moment I cancel out that square root, the restriction goes away. So anything you put into your calculator after that isn't going to take into account that restriction. So you always have to put in your original before you touch it, change it, expand it, anything like that if you want to see what the graph looks like. So second, oh, sorry, 1 second. I need bracket, square root, so second x squared, x plus 2, and then I'm going to square that whole thing, minus 5. So I'm putting that in before I cancel off that square root sign, because the moment I cancel off that square root sign, my calculator is not going to recognize that there was a restriction in the past. So I'm not going to do it. I'm going to keep it in how it is. Now I'm going to press graph. And look, it draws the graph I have now. So if you type in your final answer after you've canceled out that square root sign, it's just like typing in your final answer after you've canceled off the point of discontinuity. If you type in your final answer after the point of discontinuity is canceled, you'll never see it on your calculator. But if you type in the original before you cancel off the point of discontinuity, the point of discontinuity shows up. So make sure that you type in the original before you cancel if you want to see it on your calculator. So just a side note. All right, so now we're going to state the domain and range. So we have the domain and range. It's going to be x such that x is greater than or equal to -2. In interval notation, it's going to be -2 to positive infinity. Now you have to be able to do both methods because you don't know which way they're going to ask you on the diploma or which answers they're going to have in the multiple choice. And then the range is going to be y such that 2, 3, 4, 5. Y is greater than or equal to -5. Y, yeah. And this is the last page. And then there's some practice questions for you after this page that you can do on your own. And the answers follow at the bottom of the page. Plus there's your homework. So example number 6. Given f of x equals square root x plus 2 and g of x equals x plus 5, sketch the graph of each composite function, then determine the domain and range of the composite function. Whenever there's square roots, you have to watch yourself because you're going to get restrictions. So let's see what happens here. So I know right off the bat that this one has a restriction that x is greater than or equal to -2. But if it doesn't appear itself into the graph, then it's not going to affect it. So I have f of g of x. The first thing I'm going to do is replace the g of x. So I'm going to get f of x plus 5. So that means this little x here, I'm going to replace on the f of x with x plus 5. So I'm going to get square root. Instead of just the x, I'm going to replace it with x plus 5. And then there's still the plus 2 at the back. So now I get square root x plus 7. Okay. Punch that into my calculator. If I want to see it, see what it looks like. I'm going to punch it in before I even put the 5 and the 2 together. I'm going to punch it in this very first step right here. This step right here, I'm going to punch it in. So I'm going to get square root x plus 5 plus 2. Graph. Now, if you know about radicals, remember you guys know radical rules. Plus 0, this radical has been moved nothing up. And it hasn't been flipped in the x-axis. So my range is going to be y such that y is greater than or equal to 0, yer. And my domain, remember, it's been moved to the negative 7 to the left. It's normally at 0, 0. Hasn't been flipped at all. So my domain is going to be x such that x is greater than or equal to negative 7 yer. Now, what about g of f of x? So now I'm going to put f of x in here. So I have g of square root x plus 2. So now all the x's in g are going to become square root x plus 2. So the x plus 5 is going to become square root x plus 2 plus 5. So now our point 0, 0 has been moved to negative 2, positive 5, right? Because we moved 2 to the left, 5 up. If you want, you can look at it. Square root x plus 2 plus 5. There's been no flips, so it's still going to be greater than for both of them. I can't reduce this at all. That is as nice as it gets. So my domain is going to be x such that x is greater than or equal to negative 2 xer. And my range is going to be y such that y is greater than or equal to 5 yer. Then if we have h of x equals f of g of x, determine g of x. Okay? So let's look at these. We have our answer, x minus 4. And then we have f of g of x. This is h of x equals f of g of x. We know that we are going to have over here something squared because f is x squared, and we need to replace that something, that g, in here. We just don't know what that g is. So we have to figure out what can we put in there that when we square it becomes x minus 4. Okay? So we could put in square root x minus 4. If we put in square root x minus 4, we're technically going to actually get the absolute value of x minus 4. This technically should be absolute value of x minus 4 because the value of underneath the square root at this point in time needs to always be positive. So our g of x can be the square root of x minus 4 if h of x is the absolute value of x minus 4. Now what if we look at b? We have h of x is x squared plus 6x plus 5 equals f of g of x, because h of x equals f of g of x. Now what we're going to do is we're going to replace this x with some sort of g. So what do we have? We have x squared plus 6x plus 5 equals x squared minus 4. We need to figure out what the heck that squared could be that this would work. I know I need a 6x. The easiest way to get that would be an x plus 3 squared, and let's see if it works. Because if I FOIL this out, I'm going to get x squared plus 3x, which is 6x, and then plus 9. So let's see if it works out. So x plus 3x plus 3 minus 4. I'm going to get x squared plus 6x plus 9 minus 4. And I get x squared plus 6x plus 5, which is correct. So what's my g of x? My g of x is x plus 3. Practice exam questions. So Given f of x equals 1 over x plus 5, and g of x equals 6x minus 1, what's g of f of x? This little circle looks like it's raised, but it shouldn't be. It's g of f. It's like right side by side, like the multiplication symbol, but it's an open dot of -2. So we're finding g of f of -2. Remember, we don't want to write it like that. We always want to rewrite it as g of f of -2. Remember, when we're given a value, we just go off to the side and we find f of -2 first. So f of -2 is going to be 1 over -2 plus 5. So it's going to be 1 over 3. Then I go back here, and in for f of -2, I'm going to fill in g of 1/3. G of 1/3 is going to be 6 times 1/3 minus 1, because we're going to fill it into that function up here. And so I'm going to get 6 times 1/3 is 2 minus 1. So the answer is 1, which is A. Example 9. If if the functions f, g, and h are given by f of x equals x squared minus 1, and g of x equals 3x plus 2, and h of x is the absolute value of x plus 2, then the value of f of g of h of -8 to the nearest whole number is. So we have f of g of h of -8. We're just going to rewrite it like this always. F of g of h of -8. Then close the bracket for the -8, close the bracket for the h, close the bracket for the g. So it's kind of like a puzzle. We're going to work from the inside out. So we're going to find h of -8 first, then put it in that spot. So h of -8 equals the absolute value of -8 plus 2, which is the absolute value of -6, which is +6. So in for h of -8, I'm going to fill in +6. So it's going to be f of g of +6. So now I'm going to find g of +6. G of 6 equals 3 times 6 plus 2, because now we're going to fill into the g of x formula. So I'm going to get 18 plus 2, which is 20. So now in for g of 6, I'm going to fill in 20. So I'm going to have f of 20. And now I can just find f of 20 right here. I'm going to fill it into this function here, the f of x function. So I'm going to get 20 squared minus 1, which is 400 minus 1, which is 399. Oh, there's still another page. There's more questions to try. So we have for the functions f of x equals square root x minus 1, g of x equals x squared plus 3, h of x equals 2x minus 5, and k of x, where k of x equals h of g of f of x. The simplified form of k of x can be written to this linear equation. Determine a and b. So watch yourself whenever you have a square root, because you have to watch. There is going to be, most of the time, a restriction. So we want k of x, which is h of g of f of x. So the very first thing I'm going to do is fill in for this f of x. So I'm going to get h of g of f, which is square root x minus 1. Okay? Now, I'm going to fill into the g of x, this little x squared here. I'm going to fill in x minus 1. So I'm going to go over here and do g of square root x minus 1. So that I can just go back and insert that into this spot here. G of square root x minus 1 equals square root x minus 1 squared plus 3. Now remember, for this squared and this cancel, I have to say x minus 1 is greater than or equal to 0, x is greater than or equal to 1. And I'm going to go back here and I'm going to do my domain. It's going to be x such that x is greater than or equal to 1, because that radical is going to limit it. You have to watch. Sometimes there's a radical with inside a radical, so you don't always get the domain right away. But I'm just showing you that for this one, that would be what it would be. So now I'm going to get x minus 1 plus 3, which is x plus 2. But that's just what g of square root x minus 1 is. So g of square root x minus 1 right here, I'm going to replace with x plus 2. So now I have h of x plus 2. So now I'm going to fill x plus 2 in for this little x and h over here. So it's going to be 2 times x plus 2 minus 5, which is 2x plus 4 minus 5, which is 2x minus 1. The catch is that that whole line doesn't exist. Remember, it only starts when x equals 1. So a is 2 and b is 1. Not negative 1 because it's a, x, so a, then here's the x, then here's the minus, and then b is 1. Now, if this was ax plus b instead, a would be 2 and b would be actually negative 1. So keep that in mind. You have to watch what form they give you. Now, I told you with functions we can use any unit. So here's a log question put into it. Given f of x equals 7 log base 2x and g of x equals the absolute value of 5 minus 6x, determine the value of f plus g of 8. So we're actually doing an addition inside of a composition. So the first thing we're going to have to do is find this f plus g of 8. So what is f plus g of 8? First off, I told you never to write it like that. Rewrite it as f of 8 plus g of 8 first. Okay? So we're going to find f of 8. f of 8 is 7 log 2 base 8, which is 7 times 3, which is 21. So f of 8 is 21. G of 8 is the absolute value of 5 minus 6 times 8, which is the absolute value of 5 minus 48, which is negative 43, which is actually positive 43. So we get 21 plus 43, which is 64. So I know f plus g of 8 is 64. So I have f and then f plus g of 8. So this whole thing can be inserted 64 in its place. So now I'm going to find f of 64. So it's 7 log 2 64, which is 2 to the what is 64? 2 to the 6 is 64. So I'm going to go 7 times 6. So my answer is 42. Example 12, multiple choice. Two functions are shown below. Find the value of g of f of 3. So we want to write it as g of f of 3. So the first thing we're going to try and find out is f of 3. What does that mean? What's y when x equals 3 in f? So when x equals 3 in f, y is 5. So f of 3 is 5. So in for f of 3, I'm going to fill in 5. I'm finding g of 5. So what does that mean? Well, what is y in the g function when x equals 5? When x equals 5 in g, y is 8. So your answer is 8. And then number 13, and then your assignment, and for your textbook, and then there's 2 other pages of extra practice after. So given that the point 3, 4 lies on the graph of g of x, and the point A, 3, 8 lies on the graph of h of x, where h of x equals f of g of x, the corresponding point that lies on the graph of f of x is what? Okay. This example 13, because it takes a little bit extra, just like the one example in last lesson, we're going to do this one in class. So we're going to save that one for class example because that's one of the harder diploma style ones. Okay? So we're going to save this one and the one from last lesson too. So that is the end of 30-1 lessons. I will see you guys on Monday. Have fun.